Well, hello everyone, and welcome to our webinar on EV charger service and maintenance training. I'm April Bolduc, President of S-Curve Strategies, with over 10 years of experience in EV infrastructure projects. I'm joined by Randy Shimka, our EV charging expert and electrical engineer. And in this webinar, we will give pre-apprentice technicians, facility managers, and students some great information about EV chargers and keeping them working well. Our objectives are to help you learn about service and maintenance techniques and help get prepared for the Electric Vehicle Infrastructure Training Program certification, or whatever the next step is on your journey to becoming certified. This training session was made possible by the County of Los Angeles and the California Energy Commission. Join us for the previous session on EV charging station installations, which is also posted on the County of LA website. In addition, the County of LA and the California Energy Commission made possible a 5-part series on best practices for EV installation, which covers strategic site selection, business models and financing, regulations and implementation, permitting, and site design and operation. These can be great additions to your training today. So let's dive into the world of EV charger service and maintenance. It's great to be here. I'm April Bolduc, President of S-Curve Strategies, and over the last 15 years, I've done hundreds of EV charger site walks. I've spent a decade at SDG&E, with most of that time on their EV charger infrastructure team. And since starting S-Curve Strategies over 8 years ago, I've worked on transportation electrification projects across 13 states, and I've also been driving electric since 2011. So I'm excited to share the best practices that I've learned with you. Randy.
Hello, everyone. My name is Randy Shimka from S-Curve Strategies, where April and I have worked on various EV and charging related projects for several years. I bring over 35 years of utility engineering expertise to the table, including a decade focused on clean transportation, vehicle, and charging station projects. My educational background is in electrical engineering, and I also have a California professional engineer credential. As April knows, I'm very passionate about EVs and I drive an EV daily. In addition, my family and I take lots of all-electric road trips. We will often take detours on our trips so I can look at new charging stations and see what has been installed since our last visit. The growing EV charging network makes road tripping fun, and we try to charge in new places all the time. So I'm thrilled to be here today to share my insights with you on EV charging station service and maintenance.
Thanks, Randy. These 3 objectives will help set the foundation for our EV charging station service and maintenance discussion. We want to emphasize the importance of mastering EV charging maintenance techniques. We'll also be discussing how EV charger maintenance ensures uptime and higher user satisfaction. By focusing on consistent, accessible, and seamless charging experiences, the goal is to exceed driver expectations. Let's begin with an overview of our agenda. In this agenda on EV charging station service and maintenance, we'll start by discussing the maintenance of EV chargers and networks, followed by an overview of maintenance and what is involved. Next, we'll cover preventative maintenance strategies, some common repairs you'll see with chargers, along with a case study, and some information about career pathways and certification in EV charging service and maintenance, as well as some valuable resources that you can refer to. So let's begin by discussing the overall topic of maintaining EV chargers and networks. Randy, I'll turn it over to you.
Very good. Thanks, April. So there are 2 basic types of EV charging stations. One uses alternating current like you would have at home, and the other uses high voltage direct current, which is made by using an inverter to convert alternating current. DC chargers tend to charge vehicles faster due to their higher power, which is great for road trips, while AC chargers are slower and tend to be used over the course of many hours, either at home or at the workplace. The maintenance requirements are different for each of these due to power delivery and component complexity. AC level 2 chargers operate on either 208 or 240 volt AC power, delivering up to 19 kW via an outlet for lower powered setups or hardwired connections for higher powered setups. Maintenance is simpler for AC stations, as they tend to use standard electrical components and connectors with less thermal stress due to their lower power output. DC fast chargers deliver anywhere from 50 to 350 kW of charging power and require more complex power electronics, heavier cables, and advanced cooling systems. Maintenance challenges include managing heat buildup, cable wear, and the sophisticated electronics repairs that require specialized training and test equipment. There are key differences between the two. DC fast chargers face higher thermal and wear issues due to intense power delivery, and that requires robust cooling and more frequent inspections. AC chargers, with their simpler setups, though, they require less intensive upkeep, but still need regular checks to ensure a high level of reliability. EV charging connectors are one of the key elements to station uptime. Any issues with the connectors can stop a charging session, so keeping them in top shape is critical. Let's talk connector types. We have J1772 connectors for AC level 2 charging and CCS and NACS connectors for DC fast charging. The J1772 connector needs regular inspections to make sure the pins are in good shape and aren't bent, while the CCS and NACS connectors require additional focus on the cables and pins to make sure nothing is discolored or melted due to the higher charging power. Wireless charging is different since there are no connectors per se, but the wireless equipment does require checking or perhaps cleaning of the charging pads and basic checking of the positioning of the transmitter in the parking space to ensure efficient and safe operation. So let's discuss vehicle authentication. Using the ISO 15118 standard, chargers and EVs communicate with the networked back end to authenticate the car and prepare for the start of the charging session. Regular maintenance checks will ensure that this communication path is working correctly. In addition, many chargers also rely on RFID cards or fobs, mobile apps, or credit cards to authenticate charging access. Routine checks help to keep these systems responsive and ensure that drivers can connect and start charging with no issues. The battery management system, or BMS, on the EV is a key component. It communicates with the EV charger via the charging cable using the standardized communication protocol called the Open Charge Point Protocol, or OCPP. The BMS does several functions, such as real-time monitoring and control of the charging session. It monitors dynamic change adjustments to the power levels and also watches for faults or other safety issues while charging, like overvoltage or overcurrent situations. So when it comes to troubleshooting communication failures, they need to be detected and fixed right away so the charging station can stay online. Technicians should periodically test the network connections to the back end to verify signal strength and verify that the systems are communicating properly. And cybersecurity is a big topic these days as well. So unsecured Wi-Fi connections can expose chargers to attacks. So the charging stations need to be set up properly from the beginning and periodically checked. Follow the EV charging station manufacturers' security guidelines to help protect data and ensure secure communications, and install any software updates as soon as possible. Let's cover the maintenance of charger networks, which is a critical piece for keeping EV chargers operational. Networks connect the chargers to the provider's back-end systems and enable the billing and monitoring functions. So whether it's for tracking usage or processing payments, a stable network connection is a must. The networks rely on some sort of a communication path, such as cellular or Ethernet or Wi-Fi. Each method has its strengths, but all need regular checks to ensure proper communication signal strength. Maintaining network connectivity is essential for proper charger operation. A dropped or poor connection can interfere with user access or billing, so monitoring and fixing issues like weak signals or hardware failures is important. When network issues arise, they affect not only uptime, but also the entire charging experience for the user. Proactive steps like periodically testing connections and updating charger firmware helps to keep chargers online and ensure smooth operation. I'm going to hand it over to April now to talk about maintenance overview and the key maintenance steps.
Thanks, Randy. So let's start with routine tasks. Regular inspections, cleaning, and functional tests are the foundation of keeping EV chargers in top shape. We check for wear on the cables, clean connectors and fans, and test charging to catch issues early. Next is corrective maintenance. When problems pop up, like software glitches or vandalism damage, tackle them quickly with repairs or software updates to keep chargers operational and safe for users. To maximize EV charger reliability, proactive care is key. By staying ahead of the issues, you boost uptime, you ensure drivers can always rely on your stations. Following manufacturer maintenance schedules means sticking to their recommended checks, whether it's inspecting components or calibrating systems. This keeps everything running smoothly. And finally, create preventative maintenance calendar schedules and follow them. Set up monthly, quarterly, and annual plans to address any potential issues before they become a problem. This will help keep your chargers running well and available to drivers. Let's dive into how EV charger design impacts maintenance. The style of EV chargers directly affects how you approach servicing them, so knowing the types is key. There are four main styles of chargers. Wall-mounted units, like you see here, are compact and mounted in the front of parking spaces. Pedestal chargers stand alone and are common in parking lots. Overhead systems save ground space and are more likely to be used by fleets. And portable chargers, as you see in this photo, offer flexibility for temporary setups, for example, during an outage or while chargers are being installed at a location. Each type has unique maintenance needs. And when it comes to maintaining components, focus on screens, fans, cables, and cord management. Check screens for damage, clean fans to prevent overheating, and inspect cables for wear. Cord management systems need regular checks to avoid tangling or strain and make sure that they are still able to properly roll up the cords. For portable chargers, extra steps may apply. These units may need periodic battery charging or generator maintenance to stay functional, especially for off-grid or mobile use, ensuring that they're always ready at a moment's notice when needed.
Well, what can go wrong, April? Let's break down what can go wrong with EV charging stations. These general categories are the main culprits behind charger downtime. First, software and network issues account for about 30% of problems, including OCPP or communication timeout errors, or sometimes even firmware bugs, which can disrupt communications with the network or vehicles. Regular software updates and network monitoring can help to catch these issues early. Next, overheating issues at about 20% can happen under high loads or with poor ventilation. Fans and cooling systems need routine checks to make sure that they're working and prevent chargers from shutting down due to heat buildup. And then we have user error, which makes up about 25% of the issues. And it often comes from improper connector handling or connections or misaligning plugs or adapters. Clear user instructions, clear screen messaging, and durable connectors can help to reduce this. Finally, aging hardware, also at about 25%, can show itself with screen or cable failures or internal components failing, such as relays or capacitors or entire circuit boards. This may take several thousand charging cycles to occur. We recommend following maintenance schedules and replacing worn parts proactively to help keep chargers running longer. Well, let's jump into some physical charger issues, which can really disrupt EV charging station performance if they're not addressed. First up, we have cut or damaged cables. This can happen from vehicle impact or wear or vandalism and can lead to wires getting broken or insulation faults. Regular inspection can spot frayed cables or exposed wires before they can cause charger outages. Next, let's look at intermittent or failed circuit breakers. These mechanical devices might trip frequently or degrade over time, which would cut power to the charger. Routine testing ensures that breakers are functioning correctly and should minimize any unexpected shutdowns. And then we have connector damage. Cables on public charging stations see a lot of use. Worn pins or cracked housings from rough handling or environmental exposure can interrupt the charger to vehicle connection. Checking connectors regularly for any damage is very important for reliable charging station operation. With vandalism, there can be damaged screens or charger enclosures or broken cables that can knock stations offline. And quick repairs, such as replacing screens or cables, that helps to maintain charging station uptime. There's some new vandalism proof cables and components that are being introduced into the marketplace that can also help to minimize these issues. Let's tackle solving physical issues to keep EV chargers running smoothly, guided by the steps here. First, when replacing cables, follow NEC Article 625.23, which mandates using proper EV rated cables to fix cuts or insulation faults. This ensures safety and compliance while restoring reliable charging. Next, when it comes to resetting or replacing breakers, you can use a multimeter like the Klein CL220 or the X-Tech CT70 to test for frequent tripping or degradation. Resetting or swapping out faulty breakers can help to prevent power disruptions. For repairing or replacing connectors, stick to the manufacturer specifications. Worn pins or cracked housings need precise fixes or replacements to maintain a solid charger to vehicle connection. To reinforce enclosures, use tamper resistant bolts to protect against vandalism. This strengthens screens and casings, keeping chargers more secure and operational. And remember that NEC Article 625 is your go-to guide. It lays out the rules for safe, compliant EV charger installations and will help to ensure that all repairs meet industry standards.
Next, we have preventative maintenance strategies, Randy.
Very good. So let's get into some preventive maintenance topics that will help keep EV chargers running well. First, you'll want to monitor the charger software and any error logs or reports. Regularly check for communications or connectivity errors to catch glitches before they disrupt charging. Stay on top of software updates to help keep the charger and network running well. Next, you want to clean EV chargers regularly. Dirt and dust can clog vents, filters, and connectors and cause overheating or connection issues. Routine cleaning ensures that everything stays functional and cool. And make it a point to educate users about the proper use of the charger, connector, and any adapters to help reduce wear on pins and cables and extend their lifespan. And finally, schedule hardware replacements. Plan to swap out relays, contactors, and other parts that typically see wear after about 10,000 charging cycles or according to the manufacturer's recommended intervals. Other parts that may also need to be replaced periodically include cables and connectors, cable cooling systems and coolant, and screens. Proactive replacements prevent unexpected failures and help to keep chargers more reliable. Let's dive into the tools that you'll need for maintenance that'll help keep EV chargers in top shape. Starting with the basics, you'll need ratchets and sockets and screwdrivers, nut drivers, wire strippers, Allen wrenches, torque wrenches, and meters. These tools will make it easy to handle routine tasks like tightening bolts or checking electrical connections. Next, when it comes to working with metric and SAE fasteners, you'll need specific tools such as sockets or nut drivers or Allen wrenches that match those fasteners on the charger. Charger specs often these days favor metric fasteners, but some still use SAE types. So check the manufacturer's service and installation manuals. Having both types of these tools on hand ensures that you'll be ready for any fastener that you encounter. Other valuable items to have in your toolkit include cable cutters, crimpers, pliers, and wire nuts. These are essential for clean cuts, secure connections, and protecting against corrosion or loose wiring. Always follow manufacturer tool recommendations in their service manuals. Sometimes special tools are needed, and they're called out specifically in the manuals. Using the right tools ensures that repairs meet specs and maintain warranties. Finally, investing in high quality tools is really a smart move because a reliable toolkit is an investment in your future and it will save time and ensure professional and long lasting repairs. Let's explore the test equipment that'll be needed for diagnostics to help keep EV chargers running smoothly. The Fluke FEV100 test adapter simulates an EV to car connection, and it lets you test level 1 or level 2 chargers without a vehicle. Other meters like the Klein CL220 or the Xtech CT70 will help diagnose voltage, current, and breaker issues. These meters can also help pinpoint electrical faults quickly. Cellular signal meters are key for verifying 4G or 5G connectivity. Stable network connections ensure that chargers can communicate with their associated backend systems without issues. Charger diagnostic tools are manufacturer specific, and in many cases, they're phone apps these days. They provide special diagnostics to troubleshoot charger issues on a per brand basis. Online tools are definitely on the rise as well. So, cloud based remote monitoring dashboards let you track charger performance in real time and can help identify and catch issues early on to help maintain charger availability. I'm going to hand it over to April now to talk about documentation and reporting.
All right, for documentation and reporting, this is important to keep EV charger maintenance organized and compliant. Start with maintaining service logs. Record every fault, repair, test, and part replacement. Detailed logs track issues like cable wear or breaker trips, helping to spot patterns and plan future maintenance. Since more than one tech may work on chargers, it's important to keep good records for the next person to refer to. For submitting warranty claims, include error codes and all relevant details, like photos, timestamps, and any other information that would help with the issue. Thorough submissions help to speed up approvals and ensure that you're covered by manufacturer warranties. When documenting for certification, log maintenance hours for programs like the EV Infrastructure Training Program, and accurate records prove compliance and support technician certifications. Using manufacturer apps makes real-time issues reporting easier. Log problems on the spot, share updates with teams, and keep everything centralized for quick action. Finally, demonstrate proper workflows. Follow warranty claim processes and OEM contact protocols to ensure claims are handled efficiently and professionally. Now talking about software and firmware updates, these help to keep EV chargers running smoothly. First, apply firmware updates over the air for network chargers or locally via the USB port. This keeps chargers up to date and the latest features and security patches. Next, verify the charger software update compatibility. Check that the update is made for your particular charger model. If you have update failures, don't panic. Troubleshoot by rebooting the charger and checking the network connectivity to ensure a stable connection and apply the update again. Finally, updates and maintenance during off-peak hours to help minimize downtime. Smart timing keeps chargers available for drivers while ensuring systems stay current and reliable.
So we have some advanced diagnostics for EV charger error codes that can be a little bit cryptic, like OCPP 1.6 timeout or just the generic ground fault message. So you want to check service manuals or look on the manufacturer's website for more specific meanings and fixes so that you can quickly pinpoint exactly what the issue is. And next, you want to use any available diagnostic phone apps to access logs via the manufacturer portals to review error messages or details. This helps to make it easier to troubleshoot and resolve problems on the spot. For testing charger power delivery to vehicles, measure voltage drop at the charger using a multimeter. It should be less than plus or minus 5%. And this ensures that the charger can deliver stable power to the vehicle. Finally, you want to document any findings thoroughly, record the error codes, the test results, and the steps taken for warranty claims to streamline approvals and maintain clear records for future reference or for other technicians. Thermal maintenance management helps to keep EV chargers cool and operational. Start with inspecting the cooling systems. Check the fans and the coolant levels regularly. Make sure that heat sinks that are attached to hot running components are free of dust and dirt in the fins and have good airflow to dissipate the heat. Ensure that fans can spin freely and that coolant is topped off to prevent overheating. Next, take a look at the temperature inside the charging station. The goal is to keep charger components below 140 degrees Fahrenheit per Underwriter Lab 2202 standards. You can use thermal sensors or cameras or diagnostic tools to catch any hot spots before they can cause issues. For cleaning vents, remove dust and debris to ensure proper airflow with a vacuum or with compressed air. Clogged vents can trigger thermal shutdowns, so routine cleaning is critical for maintaining uptime. When it comes to replacing faulty fans, follow manufacturer specs and use compatible high quality parts. Swapping out failing fans promptly helps cooling systems effectively and chargers running smoothly. And finally, battery thermal events and fire response planning are critical. So we're going to dive into those on the next slide. EV battery thermal events and fire response planning boils down to understanding risks, responding safely, and preventing incidents. These incidents don't happen very often, but you need to be prepared when they do. Battery thermal runaway happens when battery temperatures spike uncontrollably, risking fire or explosion. Triggers include overcharging, cell damage, or extreme heat with warning signs like smoke or chemical odors. They can spread across the battery pack, causing additional cells to ignite and release toxic gases. For immediate response, evacuate a 50-foot radius, call 911 specifying an EV battery fire, and de-energize the charger at the circuit breaker. Ventilate if safe, stay upwind to avoid toxic smoke, and leave it to professionals. Don't approach. Prevention and safety focuses on regular inspections for damage or heat, installing thermal sensors on DC fast chargers, and following NEC 625 for proper grounding and protection. Use Class D extinguishers for lithium-ion battery fires, and try to site cars and chargers away from structures whenever possible to reduce risks. Let's discuss environmental impacts on maintenance to help keep EV chargers resilient and online. First is the issue of addressing corrosion in coastal areas. Salt spray can corrode metal components, so inspect enclosures and connectors regularly. Stainless steel enclosures are the most resistant to this type of corrosion. Next, we want to mitigate UV degradation. Sun exposure can make EV charger connector plastic brittle over time. Check for cracks or fading and replace any affected parts to maintain reliable connections. For protecting against dust getting into the charging station, ensure that chargers and enclosures have ingress protection ratings of IP54 or higher. This will help to keep dust out, but you'll still need to clean filters and seals to prevent any buildup that could affect performance. You may need to adjust maintenance frequency for harsh climates like extreme heat or cold or humidity. Increase inspections in tough conditions to catch wear or any other issues early and avoid downtime. And finally, verify the NEMA enclosure ratings. Confirm that the chargers were installed properly in NEMA 3R or 4 cabinets for weather resistance, which will ensure that they're built to withstand local environmental challenges. Let's get into commissioning and troubleshooting to ensure that EV chargers are set up correctly and can be repaired in a timely manner. First, you'll want to follow the manufacturer recommended commissioning steps. Start with voltage checks of the chargers, ensuring that you have a stable 208 volt or a 240 volt measurement that are plus or minus 5% to confirm that the charger connections are solid. Next, inspect breakers, cables, and connectors. Use a multimeter to test continuity, checking for faulty breakers or damaged cables that could disrupt power delivery to vehicles. For troubleshooting software, look at the logs and leverage any manufacturer tools or apps to diagnose issues like network connection errors or power faults. When it's time to repair a charging station, focus on fixing the issue, run all the recommended functional tests necessary to confirm that the charger works properly, and get it back online to minimize downtime for drivers. And finally, make sure to include some sort of interoperability testing as practical. Test with different EV models to ensure that the charger communications charges properly across different brands of vehicles. This will help to guarantee a seamless user experience. So on this page, we have a sample EV charger diagnostic workflow. It's all about systematically pinpointing and fixing issues to keep chargers running smoothly. In this table, we have a 12-step process that covers everything from physical checks to software and environmental factors. You'll start by inspecting for visible damage, verifying power and grounding, and ensuring network connectivity. Then it's about testing components like connectors, using tools like multimeters or testers to catch faults. If issues persist, leverage diagnostic apps and manufacturer support for deeper troubleshooting or return material authorizations to replace parts. Throughout, you're checking for things like voltage stability, error codes, or environmental issues like heat or moisture. This structured approach ensures quick, effective repairs while minimizing downtime for EV drivers.
Thanks, Randy. And what I love about this next section on common repairs is that you actually are showing us photos, some mistakes that folks have made, and a lot of times we don't really get to see these mistakes up close. So why don't you walk us through them?
Here we have a terminal block that's completely blackened, indicating either an overload or poor connections on the terminal block. So the black burning that you see, it suggests overheating from loose connections. Could be excessive current, I suppose, but that could lead to fires or even charger failure. So the lesson here is to use correctly rated terminal blocks and ensure tight, clean connections. You have to regularly inspect them for signs of any overheating, discoloration, etc. during maintenance. In this photo, we see wire splices that are green and heavily corroded, and they're wrapped only in black electrical tape. So corrosion from moisture exposure weakens the connections, increasing the resistance and the fire risk there. Electrical tape isn't really waterproof and it doesn't really meet code for splice protection. So you should use weatherproof splice enclosures or connectors that are rated for the environment and ensure proper sealing to prevent moisture from getting into the splice. This photo shows a charger on a pedestal post with visible corrosion or water damage at the base. So there's some kind of a moisture or leak issue here. Corrosion can degrade the charger's structural integrity and electrical components and can lead to a malfunction or outright failure of the charging station. So you want to use corrosion resistant materials for outdoor chargers and ensure proper sealing or drainage on the cases to prevent moisture buildup. This photo shows an open charger pedestal with a hot wire splice that's green with corrosion, all wrapped in black electrical tape. So again, it's a moisture-induced corrosion here that weakens the splice, increasing resistance and fire risk. And electrical tape, it's not really suitable for waterproofing. They make waterproof splices that can be used. So you want to use those. You want to use the weatherproof splice connectors and ensure that pedestals are properly sealed to prevent moisture from getting inside.
Thanks, Randy. Now let's get into a case study on charging station repair.
Very good. So we have a case study here to look at repairing a high-powered EV charger at a commercial site. So the issue turned out to be a problem with a cable that had an insulation fault. The solution was pretty straightforward to troubleshoot following those steps. Voltages were checked in the charger. The charger log had a cable fault error message, so that's a good clue. The cabinet was disassembled and the faulty cable was found and replaced with a compliant EV type cable, and the unit was put back together and reassembled and tested. So after testing, the charger was brought back online and everything was working okay. So this case study highlights the importance of quick diagnostics and using proper replacement parts to restore functionality. So when we review lessons from field service, it's clear that organized troubleshooting leads to faster repairs, and thorough testing after the repair is complete helps to minimize additional downtime and service calls and ensures reliable charging for drivers.
All right, career pathways and certifications. Let's explore the various EV installer career pathways that we have laid out, which maps out a clear progression from entry level to leadership roles in EV charger installation. Starting with entry roles like apprentice electrician, you're assisting with wire, conduit, and site prep while learning NEC codes and safety basics. You'll need the OSHA 10-hour course, tool skills, and enrollment in an electrician apprenticeship to kick things off. Moving to junior installer, you'll take on more hands-on tasks like mounting chargers and pulling wire, roles like charging technician that require basic electrical knowledge, site plan reading, and teamwork to support commissioning. Next are mid-level roles from technician to crew lead. The EV charger technician level, such as installer 3 or journeyman electrician, involves installing and troubleshooting level 2 and DC fast chargers. You'll need a journeyman's license, brand-specific certifications, and OCPP basics to handle network setups. As a crew lead or foreman, you'll be running the show, overseeing crews, coordinating with utilities and site hosts, and ensuring code compliance. Strong project management, NEC and ADA knowledge, and troubleshooting skills are critical to lead effectively. This pathway shows how you can grow from learning the ropes to leading installations, with each step building skills and certifications for a rewarding career in EV infrastructure installations. Finally, we have advanced roles and optional pathways. As EV infrastructure projects scale, skilled technicians have the opportunity to grow into advanced roles that support more complex and high-impact work. A commissioning specialist ensures systems are fully operational by performing final testing, configuring network settings, and coordinating with utilities and software providers, requiring strong diagnostic skills and IT familiarity. A project manager for charging stations oversees installation timelines and budgets, permitting and team coordination, drawing on expertise in construction management and clear communications. Meanwhile, an electrical engineer designs charging site layouts, calculates electrical loads, and engages with utilities and authorities having jurisdiction. It often utilizes tools like AutoCAD, and these roles offer multiple advancement pathways for those who want to lead, specialize, or design the future of clean transportation. We've put together a pathway that outlines the steps necessary to achieve the Electric Vehicle Infrastructure Training Program certification. This equips installers and technicians with the skills needed for the rising demand in EV charging infrastructure. The first step would be to obtain a journeyman electrician license or complete 8,000 hours of electrical experience, followed by coursework in electrical fundamentals and NEC compliance. Next, you would need to complete the 20-hour EV ITP course itself, which covers safety, site layout, equipment, and codes like NEC Article 625. Then pass the exam to validate your expertise so you can bid on publicly funded projects. In addition, there is an OSHA 10-hour course that includes first aid, CPR training, and this course is recommended and is often required by project managers to ensure job safety. These certifications enhance your credibility and project readiness for EV charging projects. Moving to key takeaways for our EV charger repair and maintenance webinar, pulling together the 5 main areas from the presentation. First, conduct routine tasks like inspections, cleaning, and functional tests. These basics catch issues early and help keep the chargers in top shape. Second, perform corrective maintenance. Tackle software updates and repairs promptly to restore functionality and keep drivers charging. Third, maximize EV charger reliability and uptime. Proactive care like regular checks and quick fixes ensure that chargers are always ready for use. Fourth, follow manufacturer maintenance schedules from OEMs to stay compliant and maintain a high level of performance. Finally, create sample preventative maintenance schedules, plan monthly, quarterly, and annual tasks as applicable to prevent failures, extend charger life, and minimize downtime. These steps will help to form a solid strategy and keep EV charger stations reliable, efficient, and available for drivers. We've assembled a page of links on relevant topics from this presentation where you can get more information. Here are some links that will provide additional information about best practices, installation and maintenance training, safety and standards, and charging networks. And especially that 5-part EV charger site selection best practices series hosted by LA County. And it's a fantastic series on training around site selection and installations. Thank you for attending, for watching this webinar. We hope that you were able to get some good information from all of the material. And if you have further questions, please contact the County of LA's Laura Inaconi or Jennifer Caron at the email address listed here. They would love to hear from you directly. And thanks again for your interest and time.